Just a quick reminder from Algebra 1, if you are multiplying things that have exponents, you keep the base and you add the exponents. That becomes particularly important when you have questions like this one. If you have x squared times x cubed times x, which has an exponent of 1, you add the 2, 3, and 1 to get the 6, and x remains in your answer. If you're multiplying radical expressions, you have to make sure you have the same index, because you keep the index and multiply the radicands, which are the numbers underneath, and then you simplify what you can. Just a quick reminder, that means that this little number in the upper left-hand corner of the radical symbol needs to be the same. If it does, you keep that number and you multiply the radicand underneath. Simplify each product if possible. So in number 1, this one's not possible because this first radical is a 3 and the second one is a 2, which makes it not possible. In number 2, they're both fourth roots. So you keep the 4 as the index and multiply the 8 and 2. The fourth root of 16 is 2. Number 3, the square root of 20 times the square root of 5 is the square root of 100, which is just 10. Number 4, the cube root of negative 4 times the cube root of 2 is the cube root of negative 8. And the cube root of negative 8 is negative 2. So again, number 3 can't be done because the 2 in the first radical does not match the index of the 3 in the second. Now they're going to ask you to simplify radicals that have both numbers and letters, just a review of the other day. So the square root of 9 is 3, and the square root of x to the fourth is x squared. In number 2, the square root of 36 is 6. The square root of x squared is x, and the square root of y to the sixth is y cubed. You started with an even index and ended with odd exponents, so you need absolute values around the xy cubed. In number 3, the cubed root of 8 is 2. The cubed root of a cubed is a, and the cubed root of b to the sixth is b squared. You don't need absolute values here because even though you ended odd on the a, you started odd, so it doesn't matter. Number 4, the fourth root of 16 is 2, and the fourth root of y to the eighth is y squared. So now they're going to get to the point where they're not perfect squares, cubes, or fourths like that last slide. So if you take a look at number 5, what you need to do is find a factor pair of 12 in which one of the factors is the highest perfect square of 12. So if you consult the list we got in class, you end up using 4 times 3. The x cubed can't be square rooted either without a leftover, so you go to the next lowest power that can, and the next lowest power from a 3 is a 2. The square root of 4 is 2, and the square root of x squared is x, which means that 3 and that x are inside the radical as leftovers. You started even and ended odd, so you need absolute values around the x. In number 6, if you check the list for factors of 72, you don't want to use 9 and 8 because 9 can be simplified further and so can 8. Instead, use 36 and 2. X squared is okay, but y to the fifth is not. The next lowest power of a 5 is 4, so make it y to the fourth and y. The square root of 36 is 6. The square root of x squared is x, and the square root of y to the fourth is y squared, which means the 2 and that y are left over. You did start even and ended odd on the x, so you need absolute values. Number 7 is a cube root, so you're looking at the next list that we had in class. The numbers you want to use here are 8 and 2. 8 to the fourth needs to become an a cubed a because 4 is not divisible by 3. b to the eighth doesn't work either. 7 won't work. 6 is the next lowest power, which means you need a b squared to compensate for the b to the eighth you started with. The cubed root of 8 is 2. The cubed root of a cubed is a. The cubed root of b to the sixth is b squared, which means you're left with this 2a and b squared. Don't forget to write your index in the radical. Number 8 is a fourth root. So checking your list of perfect fourths, you should be using, for 32, 16 times 2. Y to the cubed is already short. You can't reduce its power to be divisible by 4, so just keep it as a y cubed. The fourth root of 16 is 2, which means I'm left with the fourth root of 2y cubed under the radical. Then they're going to ask you to put both concepts together. So in these, you're going to multiply and then simplify. For the first one, when we multiply 8 times 6 is 48, x to the fourth times x to the third is x to the seventh. Using your list of perfect squares, you find that 48 can be 16 times 3. Make your x to the seventh and x to the sixth, and then x. The square root of 16 is 4. The square root of x to the sixth is x cubed, which means I'm left with the square root of 3x. You need absolute values around the x cubed because you started even and ended odd. In number 2, if we start by multiplying, 30 times 5 is 150. X to the second times x to the second is x to the fourth. And y cubed times y to the fourth is y to the seventh. Check your list of perfect squares for 150. You can use 25 times 6. The x to the fourth is okay, but you're going to have to make the y a y to the sixth y. The square root of 25 is 5. The square root of x to the fourth is x squared. And the square root of y to the sixth is y cubed, which means you're left with the square root of 6y. You started even and ended odd on the y cubed, so you need absolute values. For number 3, if you start by multiplying the cubed roots, 4 times 12 is 48. A squared times a is a cubed, and the b to the 8th gets rewritten. In your list of perfect cubes, you'll break the 48 up into an 8 times 6. Keep the a cubed, but make the b to the 8th a b6 and b2. The cube root of 8 is 2. The cube root of a cubed is a. And the cube root of b to the 6th is b squared, which means you're left with the cube root of 6b squared. No absolute values are necessary because you started odd. Number 4, I get the fourth root of 12 times 20 is 240, and y to the 6th times y to the third is y to the 9th. If you check your list of perfect fourths for 240, you would find that 16 is a factor. So we're going to make this 16 times 15. Y to the 9th will become y to the 8th times y. The fourth root of 16 is 2, and the fourth root of y to the 8th is y squared, which means you're left with the fourth root of 15y. No absolute values because even though you started even, you ended even.